So if we're looking at the difference of two squares formula, when they are the same values, but the only difference being a plus and a minus, we don't have to go through the FOIL process. The FOIL process eradicates those two things, the negative a times b and the plus a times b. So that just leaves us with a squared take b squared, and that was the rule. All right. So when we look at some example questions, and if I could have a show of hands, who's into this area, the 5C? Have a look at your learning. Who's into 5C? Wakey, wakey. I've got two people. Is that it? In 5C. Who's in 5D? 1, 2, 3. What are you guys in? 5E. 5E. So who's in 5E? Okay, so we're well and truly there. With these ones, where they're identical, which 2x and 2x is, 1 and 1 is, the difference is the sign. Obviously that they knock each other out. So that's simply a matter of squaring that one and squaring that number and separating them with a take sign. So squaring all of that, squaring that, leaves you with 4x squared, take 1. Okay, so that was the difference of two squares, our third distributive law. And then on Friday I went through the fourth distributive law even, where when you've got it all squared, it is the first coefficient or the first number all squared, the last number all squared, plus 2 multiplied by a times b. And if you're checking on YouTube, you see that we explained and went through that process. Again, make more use of YouTube, I think. When we've got a subtraction in there, it just becomes subtract 2 times a times b. A being the first, b being the second, and we square both of them. So that's the only difference. If we go through a couple, okay, so we're squaring the 5x to start with. Because there's a plus in there, we're plussing 2 times a, being 5x, times b, being 1, and then we add the square of the last number there. All right, so that's just following a squared plus 2 ab plus b all squared. That's following that formula. This one's got a take in it. So this law says square a being there, so you're squaring a, which is 16, but this time we are taking times 2 times a, so we can put that in there, take times 2 times a times negative 3x, and then we're adding the square of b. Alright, that's b all squared, take 2 times a times b, and a all squared, and that was 4, of course. So that practice, hopefully you're going through Friday, definitely into 5D. If you're not tracking with that, you're getting behind, and this is going to start being confusing, and you're going to say, it's all too hard. Don't give up on it, all right? You need to maintain the focus on your learning and where you're at. Check out the YouTube explanations as they come up. Please use that. If you guys are in 5E, then there's plenty to go on with, but you're not far off the end, and later in the week I'll give you a revision sheet to make sure you know where you're going right and where you're going wrong. Okay? Any questions with that? People want to drag me over, shuffle your cups, and I'll come straight to you. What is it you're starting to see in terms of a trend when you do this basic one, but when it starts to get more complicated, where you've got x to the power of 4, and then you get x to the power of 6. What trend did you find with the solutions, or how to solve them?
There's a pattern in you basically get the same result, just like with a different power each for each.
Okay, so if we just get the solution here, what's the solution to this one?
X cubed take 1.
Just like that.
Yep.
And what's the solution to this one?
X to the power of 5 take 1.
And this one?
X to the power of 7 take 1.
It's the power of 7 take 1. So we're looking for commonalities. Alright? It would appear that whatever is out in the front forms part of your answer. Would that be right? Okay. And then if we've got x to the power of 5, it's almost as if it's one more because you're doing this times this. Yeah?
Yeah.
And everything else is irrelevant.
Yeah.
This times this, and everything else is irrelevant. This times this gives you x to the power of 7, everything else irrelevant. Okay? So the pattern is starting to suggest that part of the question makes up the answer. So the constant, which is the number on its own, forms part of your answer. Okay? And you've been able to work out that the power is one more than the power that's in the original question as part of that second bracket. Yeah. All right? And we got that by saying there's a multiplication sign in here, and we're saying x times x4, x times and x to the power of 4 looks like that. And so 1, 2, 3, 4, 5, we can simplify that to be x to the power of 5, which is what we got.
Yeah.
So then they're saying, predict the simplification of x take 1 times x to the power of n, x to the power n take 1. So this might be, n might be 7. What would the answer be? We reckon it would be take 1. What would the x be? Say that was 7.
X to the power of 8.
It would be x to the power of 8. What if it was 54?
X to the power of 55.
Yeah, okay. So predict the simplification of that, or predict what the answer of that would be. It's got something to do with the n plus a value, hasn't it?
Yeah.
What's the value?
X.
Is it x? 1? What is it? You need to think about that, okay? We can predict that that's going to happen. You've got to somehow predict and write what that looks like,
Alright.
which is your challenge in the question, okay? Yeah. But you've got, you're nearly there.
Yeah, cheers.
Okay, so with these, what we're trying to use is to say we've got a certain amount of FOIL going on here. Okay, so this is distributive law, which one? No. It's distributive law 2. Which is our FOIL process. Okay. This, however, well, that's different. That's distributive law 1. And we spoke about distributive law 1. Whoops. Don't know what's going on there. Distributive law 1. And what that's about is everything outside of the brackets is multiplied with that by which is inside the brackets. Okay? So, in a way, don't imagine that's there at all. Alright, and if you do that, I'm sure you'll have no trouble doing this as FOIL. Once you've done that, then imagine that's not there. And you'll do that easily enough. Then it's a matter of just collecting like terms. Alright, so I'll just go through that with you, that first one. So FOIL for this, so imagine that's not there. So don't look at that. Do this with FOIL with me. Yeah, and are you happy with me going straight away to x squared? Yeah. Or would you prefer me to write x times x? Okay, yep. So first, absolutely, yep.
Then it's just x.
Why?
Matters.
Yep. But why? Because you're doing
It's just one.
x times 1. Yep, so it's just x, good.
And then 5x
Good.
and 5.
Awesome. Notice that you're saying 5, so I'm putting plus in there.
Yeah.
If you're saying negative 5, I'd be putting take 5. Right. So now we've done this, haven't we?
Yeah.
All done. Okay, what's next to do?
Distributive rule 1.
Excellent.
2 times x.
Excellent, which is?
2x.
Awesome.
Minus 4.
Excellent. Well done. And then we collect like terms. So this is on its own. There's nothing else that's x squared. But this, and this are all like. And this and this are alike. Okay. This one is on its own. There's no other squared there. So what would our next line be? Well, we bring that straight down. There's nothing else to do with it. Okay. What do we do with our reds?
Together.
Yep. How many have we got then?
8.
Awesome. 8x. Done, 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 done.
Would be minus 1 or
You got 5.
1.
Take 4.
I'll do 1.
Okay. I don't know if you were here last week. I was saying that none of this is a problem algebra-wise.
Yep.
Often the problem lies in the fact that we don't know our number line.
Yep.
That goes back to year 6, 7 maths.
Yeah.
So it's not the algebra that's the problem if we get them incorrect.
Yeah.
It's the fact our number.
Yeah.
Are you okay with that process?
Yep.
I'll leave you with that. Good job. Okay, so the way I'd look at doing them is I'd just probably not consider, as I turn my pen on, I'd not consider to start with that this is there. Because they're all different. Plus 1, plus 2, plus 4. So I'd probably consider they're not all there. So I'd probably start here. You've got the solution in front of you, haven't you? Let's just see if this works.
But I'm doing BD.
Yeah, we'll let.
Yeah.
Oh, okay. Yeah, well, we'll go with this and we'll
Yep.
see what. So we'd do FOIL, wouldn't we?
Yeah.
Yeah, x squared plus 2x plus x plus 2. Do that. And then I'll pop that in now. That times x plus 4.
Yeah.
Because all I've done is I've expanded this, and now I'm going to multiply that expansion by that.
Yeah.
So on this one, we're going this times this, that times that, and then we're doing this times this times that times that, that times that, and then that, and that.
Yeah.
Is that alright?
Yeah.
So, there's a lot of arrows I know. X squared times x is x cubed. And then 4x squared. Are you okay with that?
Yeah.
What's the next one?
2x times x is 2x squared.
Yep.
And then 8x. Oh yeah, it's probably 8x. X squared. And 4x.
Yep. And the next one?
2x and positive 8.
Good. My cubes. I've only got one of them. So I'm going to go with that.
Yeah.
Alright, so I've done that. And this might be the time to cross things out. Then I've got an x squared there, an x squared there, and an x squared there. So I've got 4 plus 2 plus 1.
7.
Done, done, done.
Yeah.
Then I'd do,
I can't remember the name, but you know the x's.
Yep.
So 14x